Okay, echoes. You all know what is an echo, lah? So what is an echo? The definition: echo is a repetition of sound due to the, what do you think? How do you get echo? Huh? Say again. Yeah, reflection. So it's like light like that, right? So, but this one, the sound reflects. When the sound reflects, we say it's an echo. So can you get echoes all the time? Not all the time, right? In this room, can I possibly get an echo? Not, probably not. Right? You say, but it's enclosed everything, but it's too small. But if it's a very large room, school hall, yeah, right? You shout, okay, your name hits the wall, reflects to you, okay, you can possibly hear an echo, right? Okay, but it also depends on the wall. Certain walls absorb sound, okay, so certain walls, like you go to a music studio, the walls absorb sound, so you don't have much echo. Okay, so echoes can be used for measuring large distances or to locate the location object. So it's called echolocation. So they send the sound, hit the wall, come back. Then they use that to measure distances or find objects. Okay, now to find the experiment to find the speed of sound is very simple. Okay, so it's an easy experiment to remember. Okay, so what you have is you have Brad, do you end up going shooting?
Shooting who?
NCC
Range.
Shoot who?
Okay, never mind. Okay, so
live firing bomb.
No.
no. Sadly no. So you have two guys standing at a very large distance from each other. One is Brad and the other one is Ronnie. Ronnie holds the stopwatch. Brad holds the gun. What gun you want to hold?
I want to hold a sniper.
Okay, you want to hold a sniper rifle.
Yeah.
Unfortunately, it's more boring than that. You just hold. Last time in athletics meet, they just hold what they call a starter gun.
But I'm a marksman.
You are a marksman. Okay? So, these two guys, they stand the distance. Do you think 100 meters can?
I think can.
You think can, but answer is no. Why not? Even 200 meters, you say hey, that's quite far, but also cannot. Why not?
Okay.
There's what?
Like sound travel.
Because sound travels at a speed of 330 meters per second, right? So by the time the sound reach Ronnie, it's so fast, he has no reaction, right? So to it. So these two guys must stand at a very large distance from each other. Okay, so the distance they stand from each other has to be very large. Okay, how large? Maybe like 800 meters, and it has to be flat ground. Okay, so Brad fires a gun. When does Ronnie start the stopwatch?
When he sees
I don't think he started.
When he sees the flash of light. Done in school area, right?
Yeah.
Is it? Good. No wonder very fast. Okay, so when you see the flash of light here, Ronnie starts the stopwatch. Start. So you gotta get somebody quick reaction one. So you don't put somebody slow reaction, then he won't react fast enough. So you see the flash of light. Okay, so when does he stop the stopwatch?
Hear the sound.
When he hears the sound, correct. So he stops the stopwatch not when he drops dead. He stops the stopwatch when he hears the sound. Okay, so see the flash light, bang, see the light. Then hear the sound come, stop it. That means that is the time taken for the sound to travel from Brad to Ronnie. Okay, so very simple experiment, quite commonsensical. So boy A, which is Brad, carries a, don't say sniper rifle,
A gun.
a starter gun, which once upon a time they used during athletics meets.
So the teacher said you can use flare gun also.
Flare gun. As long as anything that emits light. Okay, you use sniper rifle, you cannot see the flash. Okay,
I
while
thought you just shoot the flash, then you shoot.
boy B carries a stopwatch. You will learn next time sniper rifles, all these have minimized flash so that the enemy cannot see where you're firing from. So not good. Okay, so he starts the stopwatch when he sees the flash of light. And stops the stopwatch when he hears the sound. Okay? Simple as that. Then what do? Repeat the experiment a few times to find the average time taken for the sound to travel from A to B. Alright? Then you calculate the speed of sound using the formula. In this chapter, the speed of sound formula is very simple, something you know already. Speed equal to...
Distance over time.
Yes, distance over time. The distance between the two of them and the time that this guy measured. Okay? But the time is the average time now. Okay, you do it, you must find the average time, right? Why must you find the average time?
Cause there's human error.
You call it human error, right? Okay, to minimize what we call human reaction time error in starting and stopping the stopwatch. Why? Because everybody here the reaction time is very different. Okay, some will be fast, some will be slow. Right? So you need to repeat a few times to get it accurate. See? Okay, so be careful. Don't say to minimize human error. This doesn't sound correct. You're not a human error. It's to minimize the human reaction time error in doing what? Starting and stopping the stopwatch. Okay? Okay, then after you get these two guys also in swap position. So after Brad has shot Ronnie, now it's Ronnie's turn to shoot Brad. Okay?
I beat him.
Why do you swap positions? This will cancel the effects of what? Something. Wind. Yeah, because you're out and open. So when the wind, if there is wind direction, if there's wind, your speed of sound will be different. So if let's say the wind is blowing from Brad towards Ronnie, the speed of sound you calculate will be faster or slower. You just think common sense.
Faster.
Faster, right? You will carry the sound faster, right?
Yeah.
But if it's going the other way, then it will be slower.
Yeah.
So it's good to swap positions. Okay, so this is an experiment you could do. Again, it's not the best experiment. Okay, so there are other more efficient experiments where they use technology, okay, to measure the speed of sound. For example, like what? Okay, so all you need is, let's say, a machine. Okay, connect, and then this is a tube. This tube doesn't have to be very long. Okay, so let's say that the tube you measure a distance of d. Okay, then you make one sound. So make one sound. This machine picks up the sound, so it becomes like that. You see a signal wave like this. Then after the sound hit the wall, come back, you see another wave like that. Okay, so from the machine you can measure the time very accurately. Okay, so let's say I measure the time very accurately, so maybe it's only 0.02 seconds. You use a machine to measure rather than you down there stopwatch very slow, right? Then you know the distance, you can find the speed. Okay, so speed equals the distance over time. Then the time is 0.02 seconds. Now over here, this formula is very easy to use in this chapter. Don't get the distance wrong. Is it D or 2D? Is it D or 2D?
Just D.
Or just D? Remember, you make the sound where it hit the wall and then come back to 2D. Okay? So every time when you do questions, in this chapter of speed of sound, very easy formula to use. You always ask yourself, hey, must times 2 or don't have to times 2. It's usually commonsensical. Alright? So don't make that mistake. Alright, so this is another way of finding the speed of sound. Right? Okay, so it's not that difficult to do. Okay, so I'm gonna pause the video now and you can try question 1 and 2. He fires a gun and the sound took 1.25 seconds to arrive. Speed of sound 320. What's the distance between two boys? Very easy to do. Write down the formula. Speed equals the distance over time. Yes, what's the speed? What's the value of speed?
Distance over
Yeah, I know. What's the value of the speed?
3
Okay. Then the distance you're supposed to find, right? Must you times 2 the distance? Don't need. Why not? Because he fired, the sound just travel to him and the guy, right? Never go and come back towards him. So you don't times 2. Put that D. Then the time is simply what? 1.25. Then you times, you calculator, you times it out, you will get the answer of 400 meters, right? 400 meters, right? Okay, so it's very simple. Okay, seriously, the calculation in this chapter is like that. It's not that difficult to do. You just have to read the question carefully. So the second question, example 2, also very simple. This guy stands, boy C by the name of Caden, stands in front of a wall and makes a clap. So Caden, you stand in front of a wall and you make a clap. Okay, the sound takes 2.25 seconds to go to the wall and return back to you, right? So what is the speed of sound? So Caden, you just write down the formula. Again, speed equals to distance over time. Okay, then after that, they ask you to find the speed, right? So speed is unknown. So the distance over the time. What's the time? You see there, 2.25. You write that 2.25. So Caden, here must you times the distance by 2?
Yeah.
Yes, must not.
Yeah, because it returns.
It returns, right? So always ask yourself, must I do it? Yes. So you don't just write that 375.5. You must put that times 2. So you always ask yourself, must I times 2 or not? Then you won't go wrong. It's very easy to do one. Okay, then you work it out. You will get answer 332 meter per second. Okay. So this chapter you are using most of the time this formula, if not V equal F lambda, and it's seriously not too difficult to do it. Alright? Okay?
The close the door. Hi.
Yes. You have arrived. Warren has arrived. Okay? Pitch and loudness. What is pitch and loudness? So you got something called high pitch and low pitch, right? So high pitch voice, you know. Okay? Low pitch voice. My pitch is what? High or low?
High.
I'm high.
Low.
I'm high, then Clarabelle, you are what? Low. If you are low and I'm high, something is wrong, right? Okay, so you all know what's pitch. Okay, now the pitch relates to the sound wave frequency. Now we come just in time to Warren's favorite part of drawing. Frequency of the wave. So meaning what? High pitch you have a high frequency. And all of you remember, Clarabelle just told you 1 hour ago, frequencies and what's frequency?
Number of waves per second.
Very good. Number of waves per second. So number of waves per second. So you think number of waves per second. Okay? Then loudness. Okay, pitch is frequency, then loudness is what? Amplitude. Correct. You learn in school already. And simple meaning. I'm asking you for simple meaning. I'm not asking you for a definition. Amplitude is the what of the wave? Height. Okay? Height wave. Very easy. Okay? So here is the drawing aspect. Warren loves this a lot. Okay? Here you got always be able to know how to count. Brett, how many? Last week you forgot how to count. Now this week you can remember. Good. 2 waves. 2 waves here. So now what happens? What happens when the loudness is decreased by half? So I talk softer and then the pitch is also decreased by half.
Lower.
Okay, so the easy one
Shorter.
is the loudness You will say it's shorter. That's very easy to figure out. Okay, so you're going to draw something is half as tall. Okay, the pitch is the one that normally people draw wrongly But then again, it's not difficult. Pitch reduced by half. So all you have to ask yourself is this. Well, there was 2 waves here. If pitch reduced by half, that means I should now be drawing how many? 1. Just 1. One wave which is how tall? Half the height. Very easy. Okay, so very easy. I keep saying very easy today many times already because it is very easy. So you look, easy doesn't mean anyhow do. Easy means make sure you get it right. So you see, here to here, one wave. One wave. Within the one wave, you need to draw half a wave. So here, last year I was telling Warren, you don't anyhow draw like that. Why can't you just draw like that? That is one wave, but it's totally out of sync. Right? So must draw properly. Draw properly. So draw properly means like that. You see, this one has completed one wave. This is half a wave. Okay? So draw properly. Then after that, the other half. Okay? Then after you check, did I draw correctly? Yes, this is half the height, half the height. Purple one is down 1. Yep, correct. Very easy. Okay, so the black one, 2. This one, 1. Correct already. Okay, so this is how you draw when the pitch has changed. Alright? Okay, so it's not too difficult. Okay, so let's pause. Let's look at this. Okay, so calculate this, I guess should be no problem, right? Okay, Javier, tell me you're working for the part 1. Okay, then? Lambda equals to V over F. So V is? 2. 2 over 10. 0.2. Right? Okay, very easy. So you know the formula is like simple. Then T is equals to 1 over 进来 then 0.1. Okay, so you're going to get a question like that, as simple as this for your test. Okay, now, okay, half the loudness, or half the loudness. Pitch is double. Okay, so how are we going to draw this? How are we going to draw a new wave?
Twice as many.
Okay, let's look at the amplitude first. The amplitude is half, right? So this is half, right? Okay, so I can draw the half. I prepare to draw half. Now you got to squeeze. Okay, there are 2 waves here, right? How many more must I draw? Altogether, the new one has to be 4. How to squeeze 4? Look, so some of you know that but don't know how to draw. This one, the old one is half. So within the half, I need to draw 1. So it looks like that. And my drawing is not very good. You can see it's very out of shape. Right? This one's so fat and then this one's so skinny, right? So you can criticize and say that's not well drawn. So you gotta draw it as nice as you can. That is 1 wave. So every half now I draw 1. Draw it as best as you can. Okay? Like that. Okay? So draw it in sync and nicely. Okay, so it's very easy lah. Really not too much trouble in doing this. Okay. Here is 15 seconds. Why you look like that? To here is 1 wave. Then here comes another wave. Then again the pattern repeats itself. So you don't just count like that 1, 5. No, wrong. Okay, so actually 1 period is 15 seconds. Then after you want to get the frequency, then it will be easy already. 1 over 15. And 1 over 15 is, according to Warren, is how much with the calculator? I think it's 8, right? 1 over 15. 8, right? Yeah, so this is 0.067 hertz. Okay, so not just something different. Okay, so I got to show you this kind of a bit different question. Okay, so compression, you can label compression, rarefaction, compression. So 1 wavelength, compression to compression, 36 cm. Okay, so that's the wavelength. Yeah. That should be easy lah. I think question 3 more confusing.
So 6B answer wrong.
Oh, good. You will get there. Question 3. A bat makes an ultrasound and an audible sound at the same time. So a bat can send out ultrasound and then it also can scream. So the bat scream and send out ultrasound at the same time. So which one is true? Which is true? First of all, does it travel faster than audible sound? Okay, take note. Audible sound and ultrasound, both of them travel at the same speed. So, first one false. Right there, false. Then after that, yes, is it correct? Ultrasound and audible sound have the same frequency? True or false? False. What is true? Which one has a higher frequency? Ultrasound, right? So it's more than 20,000, right? Okay. Then C. The wavelength of ultrasound is longer than the wavelength of audible sound. True or false? How do you determine this? Skip for a while. Look at D. Ultrasound and audible sound both reach the same distance at the same time.
No.
No, man.
Yeah, then they are
Travel at the same speed.
They travel at the same speed, right? Same distance, right? So this should be true, right? This should be true. So this is D. Now, how about C? Why is C so confusing? Which one has a longer wavelength? How we determine? Look and listen. Look at the formula. V equal F lambda. Okay? V is the same for both. Both of them have the same V, same speed. This frequency, if let's say I'm talking about ultrasound, F is what? Bigger or smaller? What did I just say? It should be larger, right? This one is larger, right? Than normal sound, right? Then that means the wavelength should be smaller. Okay, that means the wavelength should be smaller. So that's why C is not correct. Okay, once more, understand what I'm doing. V is the same for both. Both of them have the same speed. Frequency, ultrasound, larger. That's why I put it larger. So if this is the same, this is larger, this has to be smaller. So that means the wavelength is smaller, whereas this one is saying the wavelength is longer. Wrong. Okay? So C is not correct. D is correct. Okay? Okay, now everybody do the next few questions. So look, why is it shorter? What happened to it? When it became shorter, that means some energy is being lost. Okay? So you all would like to write like that. Energy loss to surroundings. Be more specific. Where is it lost to? Common sense, tell me, think of something. This is happening.
Elon Musk.
This one, the ship is trying to detect the fish. So where do you think the energy is lost?
Mars.
Think where?
Fish.
Who absorbs some of the energy? Yes, the fish could absorb some of the energy, right? Where else is traveling in what?
Compression and rarefaction.
Is traveling in what? What's this? Water, right? Can the water also absorb some energy of the sound? Yes. Okay, so don't just say surroundings. Say what? Okay, some of the sound energy is absorbed by the fishes or even water. Okay, because it's traveling through water. That is one possibility. Okay, then there's another possibility. Good, okay, so another possibility is this. The ship sent out the pulse, ultrasound pulse, hit here. What happened? It went off in other directions. Okay, so you are sort of correct in that sense, but in this case, it went off in other direction. It's not captured back by the ship. Okay, so some of the pulse was reflected off into other directions. So I'll write this down.
It's okay, method mark, method mark.
Everything method mark. Everything chopped by half like that. Okay, so some of the sound energy is absorbed by the fish or water, so that's very clear cut to write. Okay, and then the other reason, some of the pulses was reflected off in other directions, so not captured by the ship. Okay, it didn't go back to the ship, it went to the seabed or something else. Alright? Okay, so that is why the pulse is lower.
Something on the shirt.
So, what is the time interval between the pulse?
My wrist game is strong.
1 square is 0.1 seconds. So, Clarabelle, what is the time interval between the transmitted and reflected pulse? What do you think? What's the time interval? They told you this already, 0.1 second per division.
0.5. You want now? Oh, wait. 0.5.
Yeah, I know.
Yeah.
But why?
I know.
You know or not? Don't know.
Cause got 5 divisions. then
This
multiply
guy,
by
this
0.1.
guy is trying to sweat physics. Bro,
So
try.
here to
I
here,
can't get out my secondary school.
got 5 squares, right? Send out, come back. Come back in between got 5 squares. And 1 square is your total 0.1 second. Right? So the time interval will be simple working 0.1 times 5, 0.5 seconds. So you need to interpret a little bit.
I think I'm way too fast already. I'm gonna copy this. Sir, I really gonna do it.
Yeah, and then everything is method now.
Yeah lah. I don't
Okay.
understand question 19 lah.
Part C then, once you can do that, then part C should be easy enough.
Sir,
How far is the fish from the ship? Again, write down speed equals distance over time. Again, write down 1200 and then ask yourself, must you times the distance by 2? And the answer is, must you times the distance by 2?
No.
No.
Yeah.
Need to, right? Why? Because you reflected, hit there and then come back, right? So you must put there 2D. 2D over the time, and the time is 0.5 seconds. So you work this out, the fishes are 300 meters away. Okay, so you use a simple formula and just ask yourself, times 2 or not? Okay,
Done.
done. That's part D. And then you see, everything that do the explanation become a little bit more difficult. But I think you also can figure it out. Right? So if let's say the fish never moved, then the ship came closer. What are the 2 changes that can be observed on this trace? You know what it's asking you not? The 2 pulses, what's the difference you will notice? So I think you can figure it out. Okay, then what will you say? What's the difference you will see? Just now the 2 pulses like that. Then if the fishes are nearer, how would this change? Okay, then give a good guess.
the
The amplitude of
the
Which one?
The second,
The reflected pulse
yeah,
will be what?
will be shorter.
Shorter, ah?
Longer.
Shorter or taller?
Shorter.
It's now nearer, no? Will it be more energy loss or less energy loss?
Longer.
Lesser, right? Energy loss. So one, the reflected pulse will be taller.
So there's no
Then-
reason.
What else can you say?
Must reason to be in
The time interval will be
Shorter.
shorter, right? This will be nearer, right? Because the fishes are nearer, right? Okay, so
Yeah, SS here. Man. Hit it with passion. It's no sec. Neon. They give you this. No? So when they didn't give you this.
the amplitude of reflected pulse will be
Hey. So is this? Cause probably I'm not white lah. I don't.
oi,
Oh.
the amplitude of reflected pulse will be higher.
Yes. That's exactly what I wrote.
And then
Word for word.
the what?
I put the time between it will be shorter. The divisions will be like
Smaller.
Yeah.
The time interval will be
Basically, do. Yes.
Shorter.
W. Yes.
Oi. I'm recording now.
Huh?
Say hi to Ron.